Hello! So today we're going to have a look at simplifying algebraic fractions, but first and foremost I just wanted to remind you what simplifying a fraction looks like. So here are a couple of questions. You've got 8 over 20 and 5 over 30. If I asked you to simplify them, it is usually given that you'd simplify them as far as possible. So that means I'm going to have a look in both the numerator and denominator to try and find the highest common factor. That is the biggest number that goes into both of these values. So for 8 and 20, the biggest number that goes into both of them is 4. You can divide by 2, but 4 generally is the biggest one. So if I divide this by 4 and divide this by 4, my numerator and denominator, then I would get 2 over 5. So I've simplified that fraction as far as possible. If I have a look in the next question, the highest common factor of 5 and 30 is 5. So I'll divide my numerator and denominator by 5. 5 goes into itself once, and 5 goes into 36 times. So that's just a quick little recap on simplifying with numbers. Now let's have a look at what happens when we introduce algebra. So here are some examples of simplifying algebraic fractions. So let's have a look at this first one. I've got 12x to the power of 4. Now that means that I've got 12 times by x multiplied by itself, a grand total of 4 times. That's why we've got x to the power of 4. And in my denominator, I have just got 3x. So if I have a look at this here, let's start with numbers. Can I do 12 divided by 3? Yes, I can. That's going to give me a whole number, so that'll give me 4. And then if I have a look at my values for x, if I'm dividing the 4x's by that one, I can cancel one of those out. And so I'm left with 4x cubed. I don't have anything left over in my denominator. Now, if you wanted to do that a little bit quicker, what you could have done is realised that if it's x to the power of 4 and then here I've got an x to the power of 1, what you can do with those powers is just subtract them. So 4 take away 1 leaves you with 3. But this middle part here is explaining why you can just subtract the powers. So let's have a look at the next example. I've got 6a squared b. So if I were to write that out, that's 6 times by a times by a times by b. And I've got all of that divided by 18 times by a times by b times by b. Because obviously the a squared is where I've got the a times by a, and b squared is the reason I've got b times b. So let's start off with our numbers. If I have a look at 6 over 18, can I simplify those? Yes, I can. The highest common factor is 6. 6 goes into 6 once and goes into 18 3 times. So let's have a look now at what we'll have left. If I look at my a's now and cancel those down, I've got that a cancels out with that a. So in my numerator, I've got an a. And then if I have a look at the b's, they cancel, but what I'm left with is a b in the denominator. So it's 1a over 3b. Realistically, do I need to write that number 1? No, I don't. So I can take that away and leave it with just the a. So I have got a over 3b. Now again, we could have seen that from looking at the powers and how they work. A squared, so subtract the 1, that means we'd have been left with an a to the power of 1 at the top. If we have a look here, I've got a b, that's the power of 1, there's 2 there, so I would get a minus 1. And we know that b to the power of minus 1 is just the same as 1 over b. So that's kind of why that b has been left in the denominator. You could have had 1/3 a and b to the power of minus 1. That would have been another acceptable way to write this, but that's a lot more difficult. So for the time being, you can leave your answers as we've got here, a over the 3b. Let's have a look at the next question. So 5a to the power of 4b squared. So if I think about that, that's 5, and then I've got a times a times a times a. And I'm multiplying that by b squared, so times by b times by b. And all of this is going to be written over 10a, and then multiplied by b 5 times. So 1, 2, 3, 4, and 5. Let's start off with our numbers then. So if I have a look at 5 and 10, they will cancel down to give me 1 over 2. So that's a half. If I have a look at the a's, they're going to cancel out there. So I'm left with a to the power of 3 in my numerator. And then if I look at cancelling out the b's, I'm left with b to the power of 3, but that's in the denominator. So 2b to the power of 3. So I could rewrite this then as a cubed over 2b cubed. Now, if I have a look at what I'd written up here, just if you're interested in trying to think about how it might get written if you were to go on to do A level, then looking at the powers, you'd have that half, so the 5 over 10 gives you the half. When you look at the powers on the A, you've got a 4 and a 1, so we know that that would be a to the power of 3. 4 subtract 1 is 3. And if we then look at the powers on the B, you've got a 2 subtract the 5, so that would be b to the power of negative 3, because 2 subtract 5 is negative 3. But these two are exactly the same. They mean exactly the same thing, because I've got an a cubed in my numerator, I've got a b, and then when that goes at the bottom of the fraction, the negative would disappear. So I've got the 2 here at the bottom of the fraction there. So these two parts mean exactly the same thing. I'm happy for you to leave your answer in the way that you feel most comfortable with. Don't worry about trying to get it in this way just yet. Okay, so the final little section that we're going to look at for this first video then is simplifying an algebraic fraction when we first of all need to take out a common factor. So let's have a look at the first example. You've got 3x plus 6 over x plus 2. It doesn't look like there's anything you can cancel down here. You certainly can't cancel down x's unless there's an x in every term in the denominator. But what you actually need to do for this one is start by taking out the common factor in the top row. What I mean by that is if I were to sort of factorise, so let's factorise in the top, if I took out a factor of 3, I'd have to multiply that by x to get 3x, and I'd have to multiply that by plus 2 to get the 6. So notice what we have now. I've got the same thing in my numerator as I've got in my denominator. So x plus 2 divided by x plus 2, they are going to cancel out, and my answer is quite simply going to be 3. You wouldn't have thought that when you looked at the question at the start, that the answer would be 3, would you? But maths is cool. Right, next one. If I have a look at that one there, x plus 3 squared, that means times by itself. Now that doesn't mean x squared plus 9. Remember, that means x plus 3 multiplied by x plus 3. So if I put both of those together, that's what we've got. Now I can see, again, that x plus 3 is going to cancel out with that x plus 3. Or quite simply, we could have just taken away a power on the bracket there. So we are left with x plus 3. Now you can write it to the power of 1, but you really don't need to. You can just leave it as x plus 3. So looking to the next example, you can probably see straight away that these are going to cancel. So that x minus 2 is going to cancel with that x minus 2. But be careful, because this time the 3 that you're left with is in the denominator. So your answer is 1/3, not just the 3 on its own. And that's it. Copy all of those examples in and then have a go at the questions.